exponential equations. And the last thing we have to finish up today, we've got one application problem where we're using an exponential function in this compound interest formula that we've practiced before. And then we're going to see a few log equations today, and then that'll wrap it up. All right, so this problem says, what interest rate is required to triple your investment of P dollars in 5 years if the interest is compounded annually or quarterly? Okay, so let's write down our compound interest formula again. You're going to want to know this for your test this week for sure. You've got this guy. This is just our general compound interest formula, and then we had PERT, which we used if it said compounded continuously, which this is not, so we don't have to worry about that. Okay, so in this problem, we don't have a starting amount or an ending amount, so we just have P, and then we want to triple P. So that actually tells you what to plug in for your first two variables. P is just P, and then the amount I want to end up with is triple that. So 3P. If it was double that, 2P, so on and so forth, okay? 1 plus my interest rate, which is what we're solving for, R, divided by the number of times it's compounded per year. So if it says annually, how many times is it compounded per year? 1. And then my exponent is going to be 1 times the number of years, which it said 5 years. The only thing that's going to change if it said quarterly for part B is it's going to be over 4 and then 4 times 5 in the exponent, okay? All right, so first thing I'm going to do to solve for R is I need to get rid of the stuff outside the parentheses before I can get into that parentheses. So P, remember, is multiplied by that parentheses, so I'm going to divide both sides by P to start. And this is why it doesn't really matter what P is, because on both sides of the equation, P is just going to end up canceling. I'm going to have 3 equals 1 plus R over 1 is just R, and then 1 times 5 is just 5. Okay. You could potentially use logs to help you here, but you don't need logs. Remember, we only need logs if you have a variable in the exponent. We do not have a variable in the exponent in this problem. We know what the exponent is. It's 5. So all we have to do now to get into that parentheses, I need to cancel out that 5th power, is we're going to use the reciprocal of 5, 1/5, and we're taking both sides to that 1/5 power. What's going to happen on the right is the 1/5 is going to cancel, and now this is where you're going to need your calculator. You need to do 3 to the 1/5 power. This is the same as taking a 5th root, so you could do either one of those in your calculator. 3 to the 1/5, and I would give it a few decimal places. I get 1.2457. I would give it at least 4 decimal places, and you'll see why in a second. Then I'm going to subtract 1 to get my R alone, and I end up with 0.2457. Now remember, R is an interest rate, so our final answer, 0.2457, really represents, and this is why I gave it those extra decimal places, 24.57%. And then it's an equation, so you could take that answer, plug it back in, make sure, you could even put a value in for P, like put $100 in for P, plug the R in, and see if you get $300 out, see if it does triple that investment if you want to check it. All right, so the second one's going to be really similar. I'm going to start by dividing both sides by P. 3 equals 1 plus R over 4. This time it's to the 20th power. How do I cancel out a 20th power? One over 20 exponent or 20th root, either one. So now I have 1 plus R over 4 equals whatever that is, 3 to the 1/20th power. Again, I'm going to give it like 4 decimal places, 1.0565. Now, I'm only writing it down just to have something there. In your calculator, you shouldn't be rounding anything. What's the next step to solve this? How do I get R alone? Subtract 1. So in your calculator, you're just going to take that previous answer minus 1. So we're really not rounding, even though it looks like we are in our work. Okay, so minus 1. And then how do I get the 4 out of the denominator? multiply both sides by 4. So in your calculator, you're going to do that previous answer times 4. And now is where we're really rounding. 0.2259 or 22.59% interest rate would be required for it to triple in that short of a period of time. Okay. Only if our exponent is a variable do we need to worry about using logs like we did on Thursday. Okay? Any questions on these two problems? All right, last few problems are solving logarithmic equations today. So these are equations where we're not using necessarily a log to solve. Instead, we have a log in the original problem, and we're actually going to use its reciprocal exponent to solve. So if we have an exponential equation, we use logs. If we have a log equation, we use exponents. We always use the other guy to solve for what we're missing. All right, so there are two possibilities when you are solving a logarithmic equation. The first possibility is that you have one log in your problem. If you have one log in your problem, you're going to get the log alone, and then we're going to write with exponents. Remember, WWE, okay? Write with exponents, then once we write with exponents, we'll be able to solve. We actually did little mini problems like that in section 4 too. The other possibility is that you have more than one log in your problem. If you have more than one log in your problem, we're going to have to use our condensing rules, where if it's like addition, we condense it and make it multiplication, or if it's subtraction, we condense it and make it division, exponents will bring down, that sort of stuff. And then we'll be able to solve from there by either comparing two sides or, again, writing with exponents. All right, so let's start with a couple problems. These problems are an example of that first possibility. We just have a single log in each problem. So the first thing I'm going to do is get the log alone, just like we did with the exponents, right? So we want nothing added, subtracted, multiplied, or divided by our logs. So in this first one, I have 4 plus 3 times log base 2 of x equals 1. I have the 4 that's added on out front. I have the 3 that's multiplied. I need to move those guys to the other side. So the first thing I'm going to do is subtract 4 on each side. 3 log base 2 of x equals negative 3. Then I'm going to divide both sides by 3. And now I have log base 2 of x equals negative 1. And this looks like problems that you guys did in section 4.2, these little mini ones. Once we get here, and I would write this little step in your notes, because sometimes people look from this step to the next step and they're like, whoa, what just happened? We're writing with exponents is the next step, okay? So how do I write this with exponents? Because that's going to get rid of my log. What would it look like? What's my base? Bases to what power? Equals x. And writing with exponents got that x alone. You just have to know what 2 to the negative first is. Remember, negative exponents move things to the denominator, so it's 1/2 equals x. And that's our final answer. Okay. Let's look at the next one. I have 1 plus 2 times the natural log of x equals 4. All right, so first thing I'm going to do is subtract 1. I get a 3. Divide by 2. I get 3/2, or you could say 1.5 if you want. And then you need to remember that natural log is what log base? What log base is natural log? Log base e. So you could always write that if you want to, bless you. Log base e of x equals 3/2 is what this means. And now again, we're going to write with exponents. So e to the 3/2 power equals x, and then that's what you're going to type in your calculator. E to the 3/2 or 1.5, and this one's going to be approximated because e's irrational, so 4.48 if I give it a couple decimal places. That one's not too bad to plug back in and check just because it's a natural log, so you could use any calculator to plug that one back in. All right. If it asks for an exact answer, like in Math Excel, if it wanted an exact answer, e to the 3/2 would be the exact answer. Questions on those two? If we just have a single log in our problem. Nope. Okay. So let's try these ones. Log base 4 of x plus log base 4 of x plus 1 equals log base 4 of x minus 1 plus log base 4 of 6. All right, so obviously we do not have a single log here. We have a bunch of logs that we need to worry about. If you have several logs, your goal is to condense the logs as much as possible. Ideally, we want a single log or a single log on both sides of the equation, which is what we'll have to do here. Okay, so on the left side, my two logs are added. So what can I condense that into? What other operation do we use that goes with addition? Multiplication. Remember, the log base does not change. It's still log base 4, but now we're just multiplying what's on the inside. So x and x plus 1 are going to get multiplied, and we can simplify that in a minute. Okay. On the right side, bless you, those are also added. So we're going to change it into, again, log base 4, multiplication 6 times x minus 1. If it was subtraction, we would change it into division instead. All right, simplifying a little bit, inside that first log, I have x squared plus x when I distribute my x through. Inside the second one, I have 6x minus 6. And that's as much as I can condense. So this type of problem, when you have a log on both sides now, as long as it's the same base, is kind of like the first problems we started out with on Thursday where we made the exponents the same base. Once we made those exponents the same base, we were able just to compare the powers and get rid of the bases altogether. The same thing's going to happen here. Once we have just a single log base 4 on both sides, the only way this equation is true is if the two things in the parentheses are equal to each other. So at this point, I can just say, okay, well, x squared plus x must equal 6x minus 6 because I compare apples to apples, right? And now we have a quadratic. We know how to solve a quadratic. We get everything equal to 0, so I'm going to move everything over to the left to keep that x squared term positive. If I subtract 6x, I get negative 5x. If I add 6 over, I get plus 6 equals 0. And then that should factor. What does it factor to? Two numbers that multiply to 6 and add to negative 5. Yep. Negative 3, negative 2. So my solutions are positive 3 and positive 2. It is possible in this type of problem where you drop those logs that you could get extraneous solutions. The last problems we just did are fairly easy. Just plug your answer back in and make sure it works. These ones get a little tougher when there's multiple logs. Here's the easiest way to tell if you have an extraneous solution. When we learned about domain of logs, you guys did this on your quiz on Friday. What's inside the log, those three guys, must always be positive. Okay, you cannot take the log of 0. You cannot take the log of a negative number. So that's where you want to check. You want to make sure that if I plugged any of those x values into each of those logs, would it still be the log of a positive number? If it's the log of a negative number, it's extraneous and you throw the solution out. So if I plug 3 in, that first one's going to be positive, the second one's going to be positive, the third one's going to be positive, I'm good. 3 works. Plug 2 in, yes, 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 both good. So in this problem, there are no extraneous solutions. Okay, but it's possible, again, if you plugged one of those in and you got a negative value inside the log, not a negative answer. Negative answers are okay, but negative value inside the log, you would throw it out and say it's extraneous. Does that make sense? Like if I had an answer of x equals -1, but my log was -1 plus 4, that's okay, because -1 plus 4 would give me log of 3, and that's a log of a positive number. So that's an example of where I could have a negative answer that wouldn't be extraneous. So you always want to plug back in and check. Okay, so let's try one more. Log base 3 of x minus 8 plus log base 3 of x equals 2. So this problem is kind of a combination of the two. I have multiple logs, so the first thing I want to do is use that addition and condense them. Again, it's addition, so I'm going to change it to multiplication. Log base 3 of multiplying x times x minus 8 to condense it equals 2. And then I can simplify a little bit more. Distribute that in, x squared minus 8x. So now I condensed, but I can't just get rid of the log because I don't have a log on both sides. I can't compare apples to apples. So instead, we're going to use the strategy we used in the first example. I have a single log. I got it alone. What's the next thing we do? Right, with exponents. So if I wrote this with exponents, it would be 3 squared equals x squared minus 8x. 3 squared equals x squared minus 8x. 9 equals x squared minus 8x. Subtract 9, x squared minus 8x minus 9. Does that guy factor? What multiplies to negative 9 and adds to negative 8? Negative 9, positive 1. So solutions are positive 9 and negative 1. Okay, now plug both of those back into our logs. Do both of those work? Remember, we want what's inside our log to be positive each time. If I plug back in 9, will both of those logs be positive? 9's good. If I plug negative 1 in, will both of those logs be positive? It actually will make both of them negative, right? Negative 1 minus 8 would be negative, or just log of negative 1 would also be negative. So that guy is extraneous. Make sense? All right, we're just going to do one more problem and then we're done. I want to do one where there's division, just so you have an example of that in your notes. I didn't have it on the slideshow. So let me grab one here. Let's do I'll do it. There we go. All right, let's try log base 2 of 3x minus 2 minus log base 2 of 5x minus 1 equals 3. That's fine. Okay, last one. I have more than one log, so we condense. Subtraction turns into division. So it's going to look like log base 2, and then I'm going to divide those two polynomials. 3x minus 2 over 5x minus 1 equals 3. Okay. If I had a log on both sides, I could just drop the logs and compare what's inside them. But I only have one log, so what's our strategy? WWE, right, with exponents. So with exponents, this would look like 2 to the third equals that big fraction. 3x minus 2 over 5x minus 1. 2 to the third is what? 2 times 2 times 2. 8 equals 3x minus 2 over 5x minus 1. Even though it doesn't look like it, you have a proportion. That 8 is over 1. You have a fraction equal to a fraction. Proportion, how do I solve it? Cross multiply to solve now. So we're going to have 3x minus 2 equals, and you can just distribute the 8 in, 40x minus 8. And then we can solve, we just have a linear equation here. So let's see, I will subtract my 3x over, that'll give me a 37x. I will add 8, that'll give me 6 equals 37x. And then divide by 37. So 6 37ths equals x. Would either of those give me an extraneous solution? Again, looking inside these logs, I want both of those guys to be positive. You could always use your calculator if you're not sure. So we need to do 3 times that number minus 2, see if it's positive or negative. 5 times that number minus 1, see if it's positive or negative. Yes.
Do we include the log?
You do not. So we are just looking at, it's really like, it has to do with the domain of our logs. Logs can only have a positive number inside that parentheses. So that's what we're checking. If we have a negative number under there, it's outside of our log domain. So that's when we throw it out. What do we think? Does it work? No, I think for sure the first one, when you plug it in, you get a negative. What about the second one? Do you get a negative in there too? Both of them? Yeah. Okay, so extraneous. So if it's extraneous and I have no other options, what's my answer? Do I have any answer? No, no solution. This is my final answer. Okay, so that's the last little bit we didn't get to last week to finish up 4-4, and that's it, guys. We just finished all of college algebra. That was it. It was everything. Isn't that exciting? Yay! Okay, so now, the rest of the period today, you guys have 25 minutes. We can work on our last Math Excel. 4-4 Math Excel is due tomorrow night, I think, but you could probably get a good chunk of it done in class today. It's over the exponent and the log equations. Tomorrow and Thursday are both review days for your test, your last test. Wednesday and Friday is when we're taking the last test. If you want to check out test review stuff, it's already online for you. Otherwise, tomorrow we'll do the first half together to prepare for Wednesday's part of the test. And this test is going to be half and half. I think day 1 is basic calculator, day 2 is graphing calculator. So you can plan accordingly. Yep. Yes, so next week is all review for the final exam, and then our final exam is until that Tuesday before we leave for break. So we've got really like 6 whole days of exam review after this week coming up. Yes.
What are we going to do? What is exam review?
What is exam review? You'll have, I think, 2 practice tests, and then I think I have like a game we can play in class for 1 or 2 of the days also. Practice tests are just going to be yours to kind of work through on your own, ask questions, but we'll have lots of time for you to be able to do that in class. So. Okay. All right, any other questions for me? Yes. All right, I'll do cell phone lotto, and then the last part of the period is yours, guys. What's that Math Excel? 10 is my cell phone lotto winner.